Hello children, today I am here to teach you an important lesson, that's chapter 29, Probability. So in this lesson, we are identifying what the fraction of success of an outcome of a random experiment and identify what the experimental probability of an event is and identify what the theoretical probability is of an event. So what is probability? Likelihood of an event occurring. So think about these instances. The rising of the sun from east. So it's definitely happening. So this event is definitely occur. The appearance of a full moon on a new moon day. So this event definitely does not occur. A coin landing heads up when it is flipped. So this is random event. We don't know whether you get heads or tails. So when you take these events, you can say sometimes it's definitely happening, sometimes not happening, and sometimes it's random. So events occur definitely. Events which definitely not occur, random events. So sometimes we call events occur definitely certain to happen. So later you will learn this word, but remember that certain to happen. Events which definitely not occur means impossible to happen. Impossible. And here random events. Events occur definitely. The likelihood of an event definitely occurs is 1. So chance of happening is 1. So we are 100% sure it will happen. So we say likelihood of an event is 1. Events which definitely not occur means impossible to happen. So the likelihood of an event which does not occur is 0. Impossible to happen. And when it comes to random events, you get a value in between 0 and 1. So when you are finding the chance of happening something, it can be varies from 0 to 1. And 0 means impossible to happen and 1 means certain to happen. And any random event, the chance of getting anything is in between 0 and 1. The likelihood of rising of the sun from east, that's definitely happen, that's 1. The likelihood of rising of the sun from west, it's not happening, so that's 0. The likelihood of getting heads up is between 0 and 1 because that's a random event. So consider flipping a coin. The chance of getting heads up or the chance of getting tails up is equally likely if it's a fair coin. So how can you write down the chance of getting heads up then? Out of 2 possibilities, you can get 1 possibility of head. Chance of getting tail? Out of 2 possibilities, there's a chance of getting tail is 1. So, chance of getting heads up or likelihood to get heads up, that's half. When throwing a fair die, it's a fair die. Getting number 1 to 6 are equally likely. If it's a fair die, all sides are equal and the chance of getting 1 or 3 or 6, all are equally likely outcomes. The chance of getting 1, what's the likelihood of getting 1? Out of 6 sides, you can have 1 chance. The chance of getting 2, out of 6, you have 1 chance. Chance of getting 3, out of 6 chances, you get 1. Chance of getting 4 out of 6, 1 chance is there. Chance of getting 5 is also the same, and chance of getting 6 is also 1 over 6. So if it's a fair die, so all sides are equally likely, so the chance of getting any number in between 1 to 6 is 1 over 6. So chance of getting 5 is 1 out of 6. So 6-sided die. The chance of not getting 5 means you can get all other possibilities. 1, 2, 3, 4, 6. So 5 possibilities out of 6. What's the chance of getting 3? That's 1 over 6. What about the chance of not getting 3? All the other possibilities, 1, 2, 4, 5, 6. 5 out of 6. Then what's the chance of getting tail when tossing a coin? We know that, half. Then chance of not getting a tail, that's getting head. That's also half. Now look at this one. 4-sided tetrahedral die. Now 4-sided die is rolled and observe the side appear on the table. So what's the chance of getting 1? Out of 4 possibilities, the chance is 1. Chance of not getting 1, all the other 3 possibilities, 3 over 4. Chance of getting 3, that's 1 possibility out of 4. And what's the chance of not getting 3? Other 3 possibilities. So when you look at all these fractions, what did you observe? If the chance of getting an event is p, any fraction, the chance of not getting that event is always 1 minus that. So when you add all these two, you get 1. So when you subtract from 1, you get the other probability or the chance of getting something. So 1 minus p. If you know chance of getting an event is p, what's the chance of not getting that event? 1 minus p. Common characteristics of a random event. So what are the characteristics? You can perform the experiment any number of times. You can toss the coin 5 times, 10 times. The result of the outcome cannot mention before the experiment. So we can toss the coin and we don't know which side will appear. So we can't say which side will come. Before the experiment, the possible outcomes of that event is known. If it's a coin, we are sure that it is heads or tails. If it's a die, we are sure that it's 1 to 6. But we don't know what will happen when after you throw a die. You can get any number, but we are not sure. Fraction of success. So we use relative frequency word. So relative frequency is the same as finding the fraction of success. Now think about a coin is tossed 50 times and observe the outcome appear. 23 times head and 27 times tail. So altogether 50. So this is 50 times it tossed. What's the fraction of success of coin landing heads up? So altogether 50 tossers. Out of 50, how many heads? 23 heads. So that's the fraction of success. What's the fraction of success of coin landing tails up? Altogether 50. Outcomes out of 50, 27. Tails are there. So when it comes to a fraction of success of A, how we find out? Number of outcomes of A divide by the total number of outcomes. So that's the fraction of success, or we call relative frequency. So what's probability? So probability is the same. So probability is the same as relative frequency or fraction of success. Consider a random experiment with several outcomes. Then the likelihood of each outcome is called the probability of that outcome. So that's another name of a fraction of success or relative frequency. Look at this one. A fair die is rolled several times and observe the outcome appear. Write down the total number of times that the die is rolled. So we need to just take the total. So we'll take the total 10, 19, 20, 30. 3 remaining. And 7, 12, 16. 16, 26 and 30. So 300 times it is rolled. So altogether 300 times. Experimental probability of getting 1. So here we use the word experimental probability. So we are rolling the die several times and observe the outcome. So what's the probability of getting 1? 47 times you got ones out of 300. So we call that's the probability of getting 1. So what's the experimental probability of getting 3? That's 49 out of 300. What about experimental probability of getting 5? 48 over 300. And experimental probability of getting 5 or 6. So either 5 or 6, 48 plus 52. 48 plus 52, you can write 48 plus 52 out of 300. That becomes 8 plus 2, 10 and 10. So 1/3. You can simplify and write 1 over 3. Experimental probability of getting 7. Can you get 7 from a die? That's impossible to happen. So 0. 0 over 300 is same as 0. You don't need to write down this 300. That's 0. Impossible to happen. Theoretical probabilities means you don't need to do an experiment. By observing the sides or the object, you can find out the theoretical probabilities. When a fair coin is tossed, write down the theoretical probability of getting head. We know when you take a coin, 2 sides are there. So out of 2 sides, one side is tail and the other side is head. So we know that out of 2, you are getting 1 head. What's the theoretical probability of getting tail? Out of 2 sides, one side is tail. So that's half. Roll a regular tetrahedral die with sides 1, 2, 3, 4. So what's the theoretical probability of getting 1? 4 sides are there. Out of 4, one side you get number 1. Theoretical probability of getting 3, one side out of 4 sides. What's the theoretical probability of getting 4? 1 out of 4. Now we'll do exercise 29.1. Write 3 events which definitely occur. That means certain to happen. So we know sun rises from east. That's definitely happening. And when you take water, water flows from up to down. That's also definitely happening. Water flows from up to down. And we see full moon on poor days. So that's also happening. Full moon on poor days. Now what about events which definitely do not occur? Impossible to happen. So you can use the opposite thing. So sun set from east. Water flows from down to up. Or you can say getting apples from mango tree. So it's impossible to happen. Getting mangoes or apples from another tree. Getting mangoes from an apple tree. So those are impossible events. Write 3 random events. So tossing a coin, that's a random event. Tossing a coin. And you can roll a die. Roll a die. Or you can take a marble from a bag. Taking a marble from a bag with identical marbles. An unbiased regular tetrahedral die with its faces numbered 1 to 4 is tossed, and write the outcomes of the experiment of observing the number on the face which lands down. So what are the possibilities? 1, 2, 3, 4. So you can get either 1, 2, 3, 4. So those are the outcomes of the experiment. Complete the table given below. You are asked to write down likelihood or the interval in which the likelihood lies, the chance of happening something. 0, 1, half, or between 0 and half, or between half and 1. A fruit dropping from a tree landing on the ground. That's definitely happening. So that's certain. That's 1. The sun rising from the east. That's also happening. That's true. If today is Monday, tomorrow being Wednesday. Impossible, because we know then next day is Tuesday. 0. A bead drawn from a bag containing 10 red beads and 2 blue beads of equal size and shape being a red bead. So here more red beads than blue ones. So the chance or the likelihood is high, higher than half. So in between half and 1. A face marked 1 showing up when a fair die with the number 3 ones, 3 twos marked on its 6 faces is rolled. So 3 chances here, 3 chances are equally likely. So that means half. Winning the toss in a match. So it's winning the toss in a match means 2 sides. So half of a chance, winning or losing. Getting a value greater than 2 when a fair die is marked 1 to 6. So what are the possibilities greater than 3 mean? Greater than 2. 3, 4, 5, 6. More numbers are there. Other side just 1 and 2. So more than half. So half and 1 in between. The sum of two odd numbers being an even numbers. 1 plus 3, 4. 5 plus 7, 12. Always an even number. So you are getting always even numbers. So that's certain. That's probability 1. The birthday of a child picked randomly from your class falling on January 2. So January 2, what can you say? The birthday of a child picked randomly from your class falling on January 2. It can be in between 0 and 1. Not definite, not impossible. So in between 0 and half. A person passing away on a Monday. So it can happen. So we can say in between 0 and half. So in this one it's given number of times the experiment was conducted. So it's done 20 times. Total number of times heads occurred. 1, 2, 3 like that. And total number of times tails occurred. Observe there. And fraction of success. So what is fraction of success? Number of outcomes divided by the total number of outcomes. And here it's fraction of success of getting tails. Here heads and tails. Now what you observe here, if this is 1, this becomes 0. If this is 0.5, 0.5. 0.33, then 0.67. So what you observe? When you add both together, that's 1. So if you want this event, you take 1 minus of the other. If the probability of an event is P, what's the probability of not getting that event? 1 minus P. So clearly we see that when you subtract from 1, you can get these values. Exercise 29.2. There are 3 identical beads in a bag. They are red, blue and yellow in color. A bead is drawn, its color is recorded and then is put back in the bag. Another bead is drawn and its color is also recorded and is put back. The outcomes of this experiment, which was repeated 50 times, are given in the table. So together it says this is totally 50 times. Find the experimental probability of drawing the red bead. Out of 50, 18 red beads are there. So 18 over 50. You can simplify. 9 over 25. Find the experimental probability of drawing the blue bead. That's 17 out of 50. Find the experimental probability of drawing the yellow bead. That's 15 out of 50. You can simplify this one. You can divide by 5, 3 and 10. 3 over 10. An unbiased tetrahedral die with the numbers 1 to 4 marked on its 4 faces, one number on each face, was tossed 40 times. So that means the total is 40. And the number on the face that landed down was recorded. The results of this experiment are shown below. Find the experimental probability of getting the number 2. 11 possibilities out of 40. 11 over 40. Find the experimental probability of getting an even number. Even number means 2 or 4. 11 and 11. 11 plus 11, you get 22. So 22 out of 40. Or you can simplify and write 11 over 20. Find the experimental probability of getting a prime number. What are prime numbers there? 2 and 3. So that means 11 plus 10. You get 21. 21 out of 40. So you can't simplify there. Find the experimental probability of getting a number greater than 1. Greater than 1 means 2, 3, 4. So that means out of 40 we can subtract 8. 32. So 32 over 40. You can divide by 4 or 8. 8 times 4. 32. 8 times 5. 40. Example number 1. In an opaque bag, there are 4 red balls, 5 blue balls and 2 green balls which are identical in all aspects except the color. Find the probability of a ball drawn from the bag being red. So what's the probability of getting red? Number of red balls over total number of balls. So you get how many reds? 4 out of altogether how many balls are there? You have to count 4 plus 5 plus 2. That's 9 plus 2, 11. So this is out of 11. Probability of being blue, that means number of blue ones over total number of blue. So blue ones 5 out of 11. Probability of being green, that means how many green ones are there? 2 out of 11. Exercise 29.3. An unbiased die with its faces marked from 1 to 6 is rolled. Find the probability of each of the following events. The number 5 showing up. One possibility. So 1 possibility out of 6 sides. That's 1 over 6. An even number showing up. So what are the even numbers? 2, 4, 6. 3 possibilities out of 6. Or you can write divide by 3, 1 over 2. A square number showing up. What are the square numbers? You can get 1, 4. So 1 and 4. 2 possibilities out of 6. Or you can write 1 over 3. There are 3 white beads, 2 black beads. 3 white, 2 black and 1 blue in a bag which are identical in size and shape. A bead is drawn randomly from the bag. Find the probability of each of the following events. Drawing a white bead. Altogether how many? 3 plus 2 plus 1. 6. Out of 6, how many white ones are there? That's 3. Or you can simplify and write half. Drawing a black bead. 2 black ones are there out of 6. When you simplify, that's 1 over 3. Drawing a blue bead. 1 blue out of 6. Drawing a white bead or a black bead. Both can happen. 3 plus 2. Altogether 5 possibilities are there. So what's the probability? 5 over 6. Next one. Drawing a bead which is not black in color. So how many black ones are there? 2. So not black means, so you have to subtract from 1. 1 minus probability of getting black is 2 over 6. So that means I can write 6 over 6 minus 2 over 6. That's 4 over 6. Or you can simplify and write 2 over 3. Then drawing a red bead. There are no red beads. So this is impossible to get a red bead from this bag. So 0. You can write 0 over 6 or 0 chance. Impossible to happen. As shown in the figure, a circular lamina is divided into 5 equal parts and an indicator is fixed at the center. The 5 parts are named A, B, C, D, E. When the indicator is rotated freely, it stops in one of the 5 parts. Accordingly, find the probability of each of the following events. The indicator stopping in D. 5 equal parts. So out of 5 equal parts, 1 part for D. 1 over 5. The indicator stopping in A or D. That means 2 parts out of 5. The indicator stopping in B, C or E. B, C or E. Now 3 parts are there out of 5. So we covered all theory related to probability. So the likelihood of an event occurring is its probability. So how we find out the probability? A fraction of success A, number of times the outcome A over total number of times the experiment is conducted. When there is an equal likelihood of each of the possible outcomes of a random experiment occurring, the theoretical probability of a selected outcome occurring is 1 over total number of possible outcomes of the random experiment. That means if it's a coin, 2 sides are there, 1 over 2. If it's a die, 6 sides are there. What's the probability of getting any number? 1 over 6. So this is a really important lesson. Practice all probability questions because we are covering probability in grade 9, 10, 11 and you are getting a one big question related to probability for your O-level exam.